All right, we're on page 155. All right, a go-kart racing track charges $5 for a go-kart license and $2 for each lap. So that pretty clearly states that after lap 1, there's a $5 initial fee plus $2 for the actual lap. So one lap costs $7. If we add an extra lap, then it's the $7 plus an extra 2, because again, it's $2 for each additional lap. So after 2 laps, it's $9, and you can see we keep increasing by 2. So this represents a sequence of terms, as labeled right below. So each of the individual parts are terms, and the entire thing is a sequence, because we have a common difference in this problem of 2. The numbers across the bottom, those are the positions of each term. And in this particular case, it's how many laps have been completed. So what we can actually do is we can write a function for this problem, because the sequence term number, 7, 9, 11, 13, that changes depending on how many laps or how many positions we've gone through. So we're going to go through this example below and how to write a function for each individual term. So first, recognize the position number or lap number. They're using the variable n, or you could use the variable x. And that represents the position number. They want us to fill in the table, which of course would be 1, 2, 3, 4, 5, 6, because we're just increasing by 1 every single time, because basically this is laps. This is your independent variable, because the lap numbers are just going to happen. The position numbers are just going to happen. And the term of the sequence, which is the money, that's your dependent variable, because that changes depending on how many laps have been gone through. And of course, we know this is increasing by $2 every single time. So 7, 9, 11, 13, 15, 17. And again, notice this is our y variable, or instead of y, they're going to use function notation. So we could also write this as f of x, or back in pre-algebra, you probably wrote this as y. So f of n is the same thing as f of x, which is the same thing essentially as the variable y. So there's some instructions below. You can read those, but basically we want to figure out, okay, what does this f parentheses 1 mean for this problem? Or what does the function at a value of 1 mean for this problem? So what we can say to be technical is it's asking this: what is this function equal to if n equals 1? There's another way to write it for this problem that may make more sense. And it's this: what is the cost for one person? Because remember, f of n, these numbers 7, 9, 11, 13, this function is talking about how much it costs to be on this racetrack. So what is the cost for a person on this racetrack after 1 lap? That's what that 1 represents, because it's this first row. And of course, these first numbers, these represent the laps. So we know after 1 lap, it costs $7. We can just look at the table. We're getting the information right there. And then f of 3 says, okay, what is this function equal to when n equals 3, or after 3 laps? And you can see it's $11. And then we're going to do the same thing at 6. So after 6 laps, it's $17. And then finally, they want us to go backwards here. They want to say, okay, let's say the function itself is equal to 13. Let's say it costs you $13. How many laps have you gone through? So we're going to look at this number right here, because that's the cost at $13, and its corresponding lap number, or n number, is 4. And then same thing here. 15, really that's $15. It wants to know, okay, what lap number or what value for n did we use to get $15? That's 5 laps. The domain and range, should be pretty obvious because they literally tell us this first row is the domain and the second row is the range. Just make sure you put your answer in curly braces there.